Hello everyone, welcome to Chapter 1, Lesson 6. This is Brianne Pernick for Robert Morris University Math 0900. In this section, we are going to learn how to use the distributive property to simplify algebraic expressions. This is, in my opinion, one of the most important lessons that we are going to cover. And the reason being that I feel this way is that because we've just finished learning how to use the order of operations. And we use the order of operations to simplify numerical expressions. We started with our parentheses, moved on to our exponents. We then took care of multiplication and division. Lastly, we took care of addition and subtraction. We performed all of those necessary calculations. We simplified the expression that we were given to evaluate our problem. With numbers, and only numbers, we can use order of operations with no problem to simplify expressions. Once an expression becomes an algebraic expression, meaning that we introduce a variable or symbol into the picture, we will often run into some sort of roadblock where we can no longer simply follow the order of operations because certain items cannot be combined together. Maybe because they're not like terms. Maybe because certain operations can't be performed first. The distributive property is going to allow us to remove these roadblocks and move around them so that we can continue on with the simplification process of our problems. So what the distributive property says is that if you have a set of parentheses and you're being asked to perform some type of addition or subtraction inside it, but you're unable to do so because they are not like terms. If you look at our little box here, we're being told to add b plus c. We know that we cannot combine b plus c because they are not like terms. So we think, I can't do anything more with this problem. I'm told to do the parentheses first, but I cannot add b plus c. What the distributive property tells us is that we are allowed to take the coefficient of that group, which is A, and multiply it into that group. So you're allowed to multiply A times B and then multiply A times C in order to remove those parentheses and move forward with your problem. So whatever number or variable is in the position of A in front of those parentheses gets multiplied by every single term that is inside the set of parentheses. This paragraph right here is going to be very important for you to explain what the distributive property is telling us what to do. This will give us exactly the same result as we would get if we were using the order of operations, if we could, okay? If we could. Now, let's look at our example problems that we have here. If the problem is an all numerical problem, you would think to yourself, oh, I'm going to follow the order of operations, right? We're told that we should do the parentheses first. So 3 plus 6 makes 9, and then we're supposed to multiply 5 by 9 to get 45, right? We know that. But our directions have told us that we should use the distributive property. So what we're going to do is take the 5 and multiply it to every single term that is inside that set of parentheses. So we would do 5 times 3, and then we would have the plus sign, 5 times 6. Okay, that's the work that we're doing. As you become proficient with the distributive property, you might find that you don't need to write those steps. So let's just simplify here. 5 times 3 makes 15. 5 times 6 makes 30. As we simplify that addition, we do see that 15 plus 30 makes 45. So in both instances, we did get 45, thus proving that the distributive property does achieve the exact same result as the order of operations. It's just another way to get there. So if your problem is all numerical, meaning you have all numbers, you definitely want to use the order of operations. Okay, it's going to be less steps. Look at the work I did on the left versus the work that I did on the right. Okay, but in the example B, you're going to see that when we have algebraic expressions, we are going to have no choice but to use the distributive property. Look at example B. In example B, we are being told that in our parentheses we need to add a plus b. We cannot do that. A plus b, or I should say A and B, are not like terms. The variables are different. They cannot be combined through addition. So what we need to do is use the distributive property in order to simplify that. So we will multiply 6 to each term inside that group of parentheses. So we'll have 6 times A to make 6A plus 6 times B to make 6B. Again, always check to see if you can combine like terms to simplify further, but in this case we cannot because they are still not like terms. So this is our final answer right there. Okay, let's look at example C. We look inside our parentheses to see if anything can be simplified, but our terms are not like terms. So we can go no further unless we use the distributive property. So outside of that parenthesis, you will notice that you have a -3. Please, please, please remember that the sign in front of the number, no matter what, is the sign that belongs to that number. Whether you're reading that string of numbers as a plus, a minus, a positive, a negative, that sign belongs to that number. So we will be multiplying a -3 to each of those. So we're going to have -3 times 3x and -3 times 2y. Please note how I wrote my negatives in there. As you continue on to do the multiplication, -3 times 3 makes -9x. -3 times 2 makes -6y. Check to see if you can simplify any further. In our case, we cannot. So we put a little box around it and we're all done. Why don't you guys go ahead and try D and E? Pause the recording, and as soon as you're ready, we will go over the answers together. Okay, at this point, everybody should have completed examples D and E. For example D, you will notice that you cannot combine B plus C plus D because they are not like terms. So in order to simplify this expression, we must use the distributive property where we are going to distribute the a to each one of those terms. So using multiplication, we will have a times b to make ab. We will have a times c to make ac. We will have a times d to make ad. Check to see if any of those terms can be combined. They cannot, so that is our final answer. For example E, we will notice that we are going to distribute a negative 2 because 5x and negative 2z are not like terms. So we will multiply that negative 2 to each of those terms. So the math that we should have done is negative 2 times 5x and negative 2 times negative 2z. Simplifying, we have negative 2 times 5 to make negative 10x. We have negative 2 times negative 2, which makes a positive 4z. Please be careful with your signs. Okay, follow your rules of multiplication with your signs. Now, one last concept that I do want to point out to you here is that when you have a negative directly in front of a set of parentheses, that is considered to be a negative 1. It's just understood that that minus sign represents a negative 1. Okay? So when you see just a negative in front of your parenthesis there, you are going to be distributing a negative 1 throughout that entire group. Okay, so what we had in this first group was negative 7a plus b, and we're distributing a negative 1 to the group. So when we multiply negative 1 times negative 7a, and then we'll have negative 1 times b, and then simplifying further, a negative times a negative makes a positive 7a, and a negative times a positive makes a minus b. And there is our final answer. For letter B, we're multiplying in that negative 1 again. Why don't you go ahead and try this one on your own? Pause the recording and we'll come back together in just a few minutes. Okay, at this point you should have completed example B, and we did distribute in a negative 1 to everything in that quantity. So we had negative 1 times A and negative 1 times negative 2B. Negative 1 times A makes negative A. A negative times a negative makes a positive 2B. So our answer is negative A plus 2B. Now we do have some more examples using the distributive property here. The first one shows that we will be distributing in fractions at times. So as you're looking in here to see if you have any like terms in your quantity that you can combine first, keep in mind that everything about those terms must be identical with regard to their variables and exponents. So we do not have any like terms that we can combine there. So as you distribute through here, you're going to have 7 halves y squared plus 42 halves y minus 14 halves. So all I've done there is multiply through on my fraction using straight multiplication. If you think of those as a 6 over 1 and a 2 over 1, just straight multiply those fractions. So the 6 times 6 gave me the 42, the 2 times 1 gave me the 2. 7 times 2 gave me 14, 2 times 1 gave me 2. Now you're ready to simplify. We'll have 7 halves y squared plus 7y, oh excuse me, that's 21y, my apologies, 21y minus 7. And there's our final answer there. In letter B, we're going to distribute in a decimal. We do exactly the same thing there. Exactly the same thing. Why don't you guys go ahead and try letter B, letter C, come back together after you're finished, and we'll solve them together to make sure you have the right answer. Go ahead and pause the recording now. Okay, at this point, everybody should have completed letters B and C. In letter B, you are distributing in a 2.1 to your quantity. So 2.1 times m squared makes 2.1 m squared. 2.1 times negative 3 makes negative 6.3 m. And 2.3 times, 2.1 times positive 0.4 makes positive 0.84. Glance across your expression to see if anything can be combined, and at this time, nothing can, so we are finished. Example C, we are distributing in a negative 2x, so you have to be careful with your signs. Negative 2 times positive 3 makes a negative 6, and x times x makes x squared. Negative 2x times positive y makes negative 2xy, and negative 2 times negative 4 makes positive 8x. Final answer, because none of those terms are considered to be like terms. Now letter D is the last example that we have here on this lesson plan here, and the reason that I saved it for last is because I just want to make you aware that sometimes the coefficient that you will have to multiply through by could be on the right hand side of your quantity. If it is on the right hand side of your quantity, it makes no difference in how you solve the problem. You can still just multiply every single one of those terms by that number. So you would simply have negative 5 times 6a makes negative 30a, and negative 5 times negative a squared makes positive 5a squared. Now, a good rule of thumb for algebra says that your terms should be in descending order according to their exponents. So that means that your biggest exponent should be written first, your smallest exponent or your constant, meaning your plain old number, should be written last. So I would want to rearrange these terms as 5a squared. Note that I don't need the plus sign when it's going to be my leading term, minus 30a, and that would be my final answer. If you left it as negative 30a plus 5 squared, it probably would not be wrong. It's just not good algebra. Okay? You should always rearrange the terms so that they are in descending order according to those exponents. As always, if you have questions, please feel free to contact me and let me know, and I will be more than happy to help you out with whatever it is that you may need. Thank you. Have a great day.